Let's study 9th standard ICSE Chemistry Chapter 4, Part 2, Chemical Bonding.
Now we know why chemical reactions take place, why bonds are created. We've also studied that there are two types of bonds, electrovalent or ionic bond, which happens between a metal and a non-metal because of transfer of electrons. And then we have the covalent bond, which is between two non-metals by sharing of electrons. In an ionic bond, the metallic atom loses electrons to become cation and the non-metallic atom gains electrons to become anion. Let's take an example of that. Now we know that sodium can lose one electron and donate it to chlorine so that sodium becomes a cation and chlorine becomes an anion. And they achieve the stable electronic configuration 2,8 and 2,8,8 respectively. And now they can attract each other to create an ionic bond, and this molecule is of sodium chloride. This is an ionic equation. Sodium loses electron, that's called oxidation, and chlorine gains electron, that is called reduction. You need to practice the ionic equations as well as these diagrams. When you draw these diagrams, it has to be with pencil and compass or pro circle. It cannot be done freehand. The cross represents electrons of sodium and the dots represent the electrons of chlorine. We're just trying to distinguish between the two. You can draw it in one line as well. Instead of vertically, you can draw it horizontally as well. Now the cross and dot structure is like this. In cross and dot structure, we don't have to draw the inner orbits. We just show the valence electrons, the outermost electrons. So sodium has one, let's call it a hollow dot. You can even draw a cross out there. And then we have the dots here. Then the next step, show the cation and the anion, and when they come together, it's NaCl. Similarly, for magnesium, we have the ionic equations. Magnesium gives 2 electrons. So 2 chlorine atoms will benefit from it because each will get 1 electron. So we get 2 chloride anions. So they will form MgCl2, magnesium chloride molecule. These ionic bonds are very stable because the electrostatic force of attraction between these ions is very strong. This is the cross and dot structure. Even this has to be practiced. We have to distinguish between the electrons of magnesium and the electrons of chlorine. So either draw dots and hollow dots or cross and dots. Notice here Mg2 plus and 2 chloride anions give MgCl2. In calcium oxide, again the ionic equations are calcium loses 2 electrons, oxygen gains 2 electrons, and there is an electrostatic force of attraction to form calcium oxide. The cross and dot structure is like this. Notice how the 2 dots here are solid dots, not hollow dots, simply because we were trying to show that they were originally from calcium. Now some properties of ionic compounds. They have very high melting and boiling points because their forces of attraction between the molecules is high, and they don't conduct electricity in solid state, but in aqueous state or fused state they will, because when you dissolve this in water or when you fuse it, that is melt it, then the bond breaks and you get the cation and anion in the solution, in the liquid, and whenever there are ions present, electricity can be conducted. Now let's talk about covalent bonds. First, the hydrogen molecule. So the hydrogen atoms, they come together to form the hydrogen molecule. Make sure when you draw, the electrons are not in between the orbits, but exactly on the orbits, like I had shown in the previous diagram. And the cross and dot structure needs to be drawn separately. Here they have mixed up the orbital structure and the cross and dot structure, but they can be done separately. All these diagrams need to be practiced. Next, chlorine molecule. So here they have shown only the outermost shell, but it is compulsory to show all the inner shells as well. So first shell, second shell, and then the third shell has to be shown. In each diagram, keep this in mind. A pair of electrons have been shared, so we show it as a single bond. In oxygen, 2 pairs of electrons have been shared because each requires 2 electrons to complete their octet and to become like the nearest noble gas. So that is why we have a double bond out here. Double covalent bond means 2 pairs of electrons have been shared. So how to draw this cross and dot structure? First of all, oxygen 1, 2, 3, 4, 5, 6. I'm just showing the outermost shell for cross and dot. Plus oxygen 1, 2, 3, 4, 5, 6. So each requires 2 electrons. So they will share it. 1, 2, 3, 4. They're sharing 2 pairs of electrons. And these lone pairs of electrons will remain as it is. So by doing this, what's happening is this oxygen seems to be having 8 electrons now. Even this oxygen seems to be having 8 electrons now. So they become stable. And since they're sharing 2 pairs of electrons, we say they have a double bond. Double covalent bond. Covalent bond. Next, nitrogen. Well, they share 3 pairs of electrons, so they have a triple bond. So that's the kind of question which is asked in exam, like draw the atomic structure diagram or orbital diagram for a molecule with triple bond. So here it is. Make sure the electrons are not between the orbits, they are exactly on the orbits. 1, 2, 3 here and 1, 2, 3 here. And show the inner orbits as well. Then we have hydrogen chloride. They have a single covalent bond. However, there's something special about HCl. What's special is that although for namesake they are sharing this pair of electron, but chlorine is more electronegative. You can say it is more, it is greedier than hydrogen. So these electrons are closer to chlorine and far away from hydrogen. It's almost as if hydrogen is about to donate it to chlorine. That way, hydrogen will become slightly positive and chlorine will become slightly negative. See, it's not an ionic bond. If it was sodium chloride, then of course sodium would give away the electron and it will become cation. But hydrogen is not as generous as sodium. Yes, chlorine is trying to snatch away the electron for itself. It doesn't want to share. But hydrogen will hold on to it. So I would say that this bond is in between ionic and covalent bond. This bond has the properties of both ionic and covalent because they are sharing like covalent bond, but there is a slight charge separation like an ionic bond. So it has a special name called polar covalent bond, which is not there in your syllabus. It's there in 10th standard, but you should know about it. And there are only 2 polar covalent compounds we have to study in our syllabus: HCl and water. For 9th standard, just know that these 2 are polar compounds. The rest of the compounds like ammonia, ammonia is also polar. So we have got 3, HCl, water and ammonia are polar. And the remaining compounds, carbon tetrachloride, methane, these 2 are non-polar. And of course the elements, that is oxygen, chlorine, hydrogen, nitrogen, they are all non-polar because those are elements, not compounds. Here they have mentioned non-polar compound. Well, everywhere that's wrong. Nitrogen is not a compound, it's an element. Even here, non-polar compound, no, it's an element. You can say non-polar molecule. Even here, chlorine is not a compound, right? Compound has 2 or more atoms. Now what about water? Well, oxygen is sharing 1 pair of electron with each hydrogen atom. And with nitrogen, please draw the orbital diagram separately in one line and the dot and cross structure separately in another line. Let me draw the dot and structure, cross and dot structure for ammonia. So we've got nitrogen here. It has 5 electrons, 1, 2, 3, 4 and 5. It needs 3 more electrons. And then we have hydrogen, which has just 1 electron. Hydrogen with 1 electron and hydrogen with 1 electron. Addition. So what is formed here is nitrogen 1, 2, 3, 4, 5. hydrogen cross, and hydrogen cross. So use a cross even here, just to distinguish between the electron of hydrogen and nitrogen, because in exam you won't be able to use colored pens, different colored pens. And then hydrogen, single bond, single bond, single bond. And of course a lone pair which doesn't participate in any bond formation. So this is a polar compound called ammonia. It's called polar because they are sharing electrons, but actually these electrons are closer to nitrogen and far away from hydrogen. So nitrogen is slightly negatively charged, and hydrogen atoms are slightly positively charged. Not very important, but we should know that this is a polar compound and why it is so. Now, this has 3 single covalent bonds. If they say triple covalent bond, that was the nitrogen molecule, triple covalent bond. Here we have 3 single covalent bonds, that is nitrogen is sharing 1 pair of electron with each of the 3 atoms. Look at the wording, how to write the sentence. You have to learn these sentences from the textbook. If they ask in exam, you cannot write in your own words and mess it up. Similarly, in carbon tetrachloride CCl4, we see that the carbon atom is sharing a pair of electron with each of the 4 chlorine atoms to form 4 single covalent bonds. And same thing is happening with methane as well. Carbon has 4 electrons in the outermost shell. It needs 4 more electrons to become stable. So it will take 1 electron each, or rather share 1 electron pair each with each of the 4 hydrogen atoms. So it has 4 single covalent bonds. As you can see here, a pair of electron, pair of electron, pair of electron, and pair of electron with each of the 4 hydrogen atoms. So even hydrogen is satisfied, the duplet is satisfied for each hydrogen, and an octet is satisfied for the carbon atom. So it becomes stable by sharing. Covalent compounds, remember, unlike ionic compounds, they are different because they have low boiling and low melting points. Since the intermolecular force of attraction is weak, they are non-conductors of electricity because they don't have ions, and they are not soluble in water, unlike the electrovalent compounds.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.